Hey guys, Rev from Into Gaming. Today I'm going to do a little bit more in-depth video on sound attenuation, mainly focusing on the attenuation shape, its inner radius and fall-off distance, and how to apply custom curves to the shape so that you're getting the intended results. Um, it sounds easy enough, and most would assume to go about it a certain way, but in practice, it's not so obvious. Um, so this is pretty much targeted to anybody at any level of Unreal Engine 4 development, because I know of really competent developers that have been messing with Unreal Engine since the 2.0 days back in 2001, and they still get lost when playing around with sound and the attenuation. So um, for those guys, hey, this is going to be a refresher course. And for you new developers, this is just going to give you that aha moment. Um, anyway, we're going to add a sound to our world here. So I'm just going to use an ambient sound. I'm going to drop him over there, clear this out, and I'm going to go to orthographic top so I can position him where I want it. So I got a little sphere in here in our little world down here, this little guy right here, to give us a reference point of where the sound's coming from. And I'm just going to hit it and snap it to the floor, because basically what we're going to be dealing with is a footstep sound. I'm going to set it up to where it's a looping footstep sound so that it's, we can test it and so forth, and etc., etc. Alright, first off, when you add a sound to the world and you play it, it's by default it's at 100% volume, or whatever your base volume is that you set up for it. Let me go ahead and add this looping. So what I'm adding here is this looping over here. Little setup, I have 6 footsteps in grass, and I'm using a random node to randomly choose one. I'm going to modulate it a little bit, and then I have the looping so it loops. I'm going to go ahead and play this out. The key here is you'll notice that my volume multiplier here is set at 0.5. So it's basically each one of these sounds is being dropped down to 0.5 of its wave file source. So like if I open up this file, it's a wave, its volume is 1. It's just a wave. And it's set at default, so we want to adjust out the output here. Getting further into development of this type of stuff, you would go to each little individual file and play it and play it and play it and play it until it was at the max volume you ever wanted it to be played at on your level. So in this instance, this footstep loop sound, its max volume is set to 0.5. And I'll show you the differences. This would be 100% of source. But we're gonna stick with the 0.5 because this is the maximum value I want the sound at source to be when my player is running. So when he hears his own footsteps, this is as loud as I want it to be when we're dealing with a default volume kind of scenario. When he's got his system set at probably about 40%, 50% normal game volume type scenario. He might have master volume slammed in game for sound effects, but his Windows volume is going to be about 40%, 50%, somewhere around in there. So this will probably just be barely audible. It's in a realistic kind of setup. Decibel wise, we're looking at anywhere from 5 to 30 depending on the speed of impact and all the other physics applied. But anyway, set your volumes. This is key right here. Is you set your max volumes from your source, which is going to be the sound cue, to where you want them to be at max, because this affects your curve. Curves. Jumping ahead here a little bit, curves. They're done volume, distance, volume, distance. And generally when you're creating a custom curve like this and not using one from the system itself, some of the built-in, you want to map out to a 1-to-1. So here's the 1, so my last key is at 1. Whatever this value is here gets stretched off into infinity. So this is my last key, but it's noted that it's at 1, which is 100% distance. Volume starts at 1, which is 100% volume. Just to be clear on that, that's what we're dealing with. So when we apply, we're starting off with our volume here. So, and then we can go 0.9 is 90% of this value, and so forth. So just wanted to get that out there because a lot of people just throw it in default, whatever it is. They pop it off at 1, and then they get over here and start having to tweak things, and it just never just works out to exactly the way they want. Set your source files volume at the max that you ever want it to be in your game world, and then tweak things on this end, especially with attenuation. So your volume multiplier, when you're applying attenuation, you want it at 1. You just want to start at 1 and let your graph, your curve, handle things at distance correctly, so there's no screw ups there. Anyway, going from there, what was I talking about? Okay, attenuation not being applied. By default, it's not being applied, so regardless of where you are in the world, you get 100% volume of the source. There's no attenuation, period. Regardless of distance. So what you want to do is turn it on, and that's just override attenuation. As soon as you hit override attenuation, your sound source gets the default sphere. Let me collapse this, I don't need that anymore. We get the default attenuation function of linear. And here's the other defaults, and then you can go to custom. The default shape is a sphere, which has a inner radius, and then we have our buddy, the fall off distance, the pain in the butt guy. Shapes, 4 of them: sphere, capsule, box, and cone, and they're exactly what you think they are. A capsule is the pill shape, so I'm gonna get this guy going here. I gotta get him up to a certain size, and then adjust the fall off distance, adjust this, and now we're starting to get that crazy pill shape. It's a pill. Let me get down here so you can see it below the map. See, it's a pill shape. So that's that. Capsule is pill shape. Then we have our box, which deals with extents, X, Y, and Z, so 400, 400, and 400, and we'll take this down to a decent value, and then we have a cube within a cube. It's your inner cube, your inner extent, same as an inner radius for sphere, and then you have your fall off distance out here. But for this purpose, since we're going to be dealing with footstep sounds, we're going to be working with a sphere, which has an inner radius, and that inner radius we have here is 400 centimeters or 4 meters, and the fall off distance is 50 meters, 5,000 centimeters. How this applies: attenuation applies from the edge of your inner radius, the outside edge of the inner radius, outward. So 5,000 or 50 meters starts from the edge of the inner radius. So from right here outward, get up here and do an orthographic top and scale out. So from this point, this edge, the outer edge, outward is where your attenuation is applied, and your attenuation is stretched to fit that distance. So if you're using a logarithmic that starts at 0 and it ends at 100 or 1, which would be 100%, it's going to fit nicely in that distance. Boom. This point will be at the outer edge and your start point will be right here. Done. For a custom curve like this would start at your inner edge right here and then be stretched. This point is seeing this is the last key, will be stretched out to hit this. But it's all kind of a universal stretch, so it's a one-to-one stretch, so it's something like that. It's stretching it out like that, so everything gets moved out accordingly, or elongated to fit. It's elongated to fit is more accurately what's going on. So that's what's happening there. So for footstep sounds, we want to have an inner radius of 0. So if I'm using a standard logarithmic curve on this, what we're going to do is at this point we're having 100% source. Out this point it's going to drop down to 0. If we're using the custom, let me see, custom one, which is this guy, it's 0.1 or 10% of source volume, 100%, 10%. But as with all attenuation setups and shapes, no sound from this source penetrates the outer edge of the fall-off distance, period. So you have that. So let's look at if I wanted to apply this particular curve to my sphere shape and have this point accurately be set at 35 meters, because in my game I want the volume of footsteps to be 20% of volume, 20% of the source volume at 35 meters. That's where I kind of want to set it up. So I don't want you to really be able to hear footsteps past that mark. But we also need this little drop off because you can't have a 0.62 time in 2 positions in the graph. But we want to give it a little bit. We're giving it basically 3 key steps, or 3%, 3 frames basically in this to drop from 20 to 0. So the accurate way to do this is very straightforward. But I think I'm going to finalize on that note. I'm going to show you what everybody assumes. The assumption process. The assumption process is to just say, okay, let's just set our fall-off distance to 3,500. Boom. Hey, we're done. That was easy. That's incorrect. Because our curve doesn't reach the 1.0 point, this is being stretched out to 1.0 in that distance. So what it ends up being is this point will end up at 62% of the sphere, which is right around here. So I got my, this is my 35 meter mark, 35 meters. This is where that actual sound would kick in, using the custom curve here. And I'm going to just show it to you, make sure. Let me see, spatialization. I want stereo for overlapping. And we're going to play it. Alright, here's the edge of our curve. Here's our fall off. And this is my 20%. So the base assumption is if I want my fall off at 35, that it would start right here at the 35. I'd start hearing it at 35, and that's not the case. Obviously, you can see it. So that's one assumption. The other assumption is to, you know, calculate for those extra 3 frames. So 3,500 plus a little bit to extend the fall off a little bit to account for this little drop. But that's just 3 frames, so you know we should have some really easy math. Like let's take 3,500, that's where we want this to be, divide it by 62, because that's this number, that's 62%, and then just multiply by 65 to get those extra 3, and well, that didn't calculate right. 3,500 divided by 62 times 65 equals, yeah, there. Then we'll have that extra. It was basically 169 centimeters, or 1.69 meters. We're going to add that. So let's do that. And let's actually do that. 3669. You just round it down to a whole number. So now we have that extra little thing right here to account for this little thing, that little short distance. So great. And then now when we play this, what should happen is no sound, and then 0 right at the edge, and then a sharp climb to right here, and then I get my 20%. And that's not the case. And I'll just go in here and show it to you. I should have 20% volume here. But I'm getting it here. Or right around in here. I'm getting it close by here. So why is this not working? Because you're getting stretched out. And I'm going to show you the math again, but we're going to just flip it a little bit to show you what's going on here. What's going on? We're going to take this starting number. So we started off at our fall off at 369. 3669. 3669. We're going to divide that by 100 and then multiply that by 62. 2274. 22.74 meters from source, which is right around this marker, is where we're getting our 20%, because it's 62%. So the attenuation curve is basically what it's doing. It's trying to take this key point and maintain it within its stretch. So 62% of the stretch point is going to be this volume, and at 65% of it, we're going to have it at this volume. So the correct way to do this, ladies and gentlemen, the correct way to calculate your fall off distance using a curve like this that does not have a key at the 1.0 or doesn't end at the 1.0 in the graph, is to find your point that you want, your key point that you want volume to start at. For this example, we're saying 35 meters. So 35 meters. So we start our math with 35 meters. Divide by the time as a whole number, 62, as a percentage basically, 62% times 100. And we get 5645. So back over in our map, 5645. We're just going to round it. Don't need that 0.16, etc. Because, I mean, if you break this down, it's going to actually be 3,499.9 centimeters to where our mark is. So basically here, this is set up dead center on 35 meters, and it's just slightly in from it. So no whoop, we're not losing anything. We're 0.1 centimeters. So let's get out here and play it. And actually, I'm gonna go from here, and I think here I'm just gonna eject out and resume, and then I'm gonna click on our ambient so we see it. So our guy is way outside the zone. 20% right here. fall off starts, and boom. So basically what we're doing with this number is accounting for the other 35% of the stretch and applying 0 to it. So so at the 65% mark, which is ballpark right around here, 1.69 meters off of that point. From that point outward, it's just null space. It's not getting any audio because 0 times, let's look at it, 0 times whatever amount of compression, whatever amount of volume on Windows or your sound card or whatever is always going to be 0. So that's it. You just have to account for the distance from here to your 1. So hopefully that makes sense and gives a better understanding of how to accurately set up your attenuation curves and apply them with a fall off distance. Yeah. So any questions as usual, ladies and gentlemen, just hit me up in the replies or hit me up on Discord. Always welcome to help. Have a good one.